Hello and welcome to this video in the Introduction to STEM Programming with Python 3 series. This video is entitled Definitions, also known as Functions or Subroutines, and goes along with Chapter 8 of our textbook. I'm James Reneau Ph.D. from Shawnee State University, and I'll be taking you through this presentation. In this video, I'm going to cover how to create your own definition or function, how to pass values and references to a function, and how to return values back out of a function. So to start this discussion, I first want to define what a definition or a function is. What it is, it's a block of code that's reusable. Um, Usually within one program, it's used in multiple places, or it can even be used in multiple programs. The idea is that you create a block of code, a definition for something that you're going to be doing over and over again. Um, it simplifies maintenance because once you get it working right, get it debugged, you don't really ever need to look at it again. You can even give it to another programmer, and as long as they understand how to use it, they don't really have to know what goes on inside the definition. Another advantage to a definition is that it has its own variables. So if a variable exists outside the definition and the same name is used inside a definition, usually they're two distinct variables, so you don't clobber the values outside the definition. Definitions are also part of creating classes, and that comes in Chapter 9 of the book. To start a definition, you use the word def or the keyword def followed by the name of the definition, and then a set of parentheses, and we'll put some things inside those parentheses in later examples, followed by a colon. Then, like with the if statement and like with other statements that have suites, we indent the suite of code that belongs to the definition. And when we're done with the def, we unindent. So a def starts with the letters def space, the name of the definition, because we're extending the language and we have to give it a name. The same naming rules that go into how to name variables also apply here, followed by open and close parentheses, followed by a colon, and then the suite of code following that. Let's look at some examples. Here I created a definition called do it. And you can see that it follows the syntax that I described in the last slide. And on line 2, it has a print statement that says, I did it. It's by far the simplest definition you'll ever create. It really is kind of nonsensical because it doesn't really do anything. But you can see on lines 4, 5, and 6 that I called the definition, and the results was it printed, I did it 3 times. So there's a simple definition. A simple definition like the one you just saw is way too simple to really do anything meaningful with. So what I'm going to show now is how to pass values into a definition. So in the parentheses in the definition, you can then put a list of variables, and those variables are going to get values from the calling program. We call that passing values. Now, in Python, values are passed as a reference. So the variables existing in or the variables defined in your definition statement point to the values that exist outside the definition. We'll look at why that's important in another example. Just remember they're passed as a reference. Variables you create inside the definition, variables that you create that are unique inside the definition are unique and local to the definition. So if you have a variable A outside the definition that has a value, and then you assign a value inside the definition, you assign it a new value, then, and you didn't pass it, it didn't include that in the arguments in the definition, then it's absolutely a unique and new variable and doesn't clobber the value outside the definition. That makes it that much easier and that much better to use definitions because they have their local variables, and you don't have to worry about what variable names you use outside the definition or inside another definition. Let's see some examples. So let's look at this definition I call calc price. Let's imagine we have a small business and our normal prices are the price is the quantity times the base price. You can see that online too. But then we give discounts. If the extended price, the quantity times the base price, is greater than $100, we automatically give 10% off. You spend more than $100, we'll lower the price by 10%. If or else if. Now notice that I'm using an elif. Um, so if the price is greater than 100, we give them a 10% discount. If they buy more than 10, we give them a 5% discount, but the discounts don't pile on top of each other. If you buy more than 10 for more than $100, you don't get 15% off or you don't get it compounded. You get one or the other, the bigger discount. And you can then see on line 7 that the word price is printed, that the variable price is printed. So we can see that on line 9 and 10, I sell one Fuzap for $23.45, and you can see up above, one Fuzap costs $23.45. You can also then see on line 11 that I sell 5 Fuzaps at $23.45, and it extends that price. But because $23.45 times 5 is greater than $100, the price that's shown is the discounted price by 10%. And you can pull out your pocket calculator and see that. You then see that down below on line 14 and 15, I print the word 10 tiny zips cost, and tiny zips only cost 38 cents a piece. So if we sell 10 of them, that would be $3.80. But because we give them a discount of 5% if we sell more than 10, greater than or equal to 10, that's what it says on line 5. You can see the discounted price is not $3.80, but $3.61. And because we bought 100 tiny zips, we're still under the $100 range, so we only get the $5 discount. So you can see how that function could come in real handy. And if you're writing a retail program or you've got a whole lot of different things, once you write the function once, you don't really even need to know how it works. You just trust that it works. You've debugged it. Somebody else maybe wrote it for you, and it works just the way you want it to. There's an example of a function printing out a value. As I said before, values are passed to a definition by reference. So if you use a variable in the definition, when you're calling the definition, when you're calling the function, the content of that variable is sent. There are a couple of different types of variables that are being sent. Um, Lists, objects, dictionaries, and many other types, classes and such. Changes made in the definition will change outside. So if you pass a variable containing a list to a definition, and the list changes and the definition changes that list, that variable that it received it into, it will change it in the code outside. You got to be really careful when passing um, this type of stuff to a def. If you pass an integer, float, string, boolean, and tuple, those are immutable. And if you change the past variable in the code, it actually creates a new copy, and it is local to the definition. Let's look at an example of that because this gets a little confusing dealing with variable scoping and mutable references versus um, non-mutable references. So let's look at an example here on the next slide. So here in this example, I have two functions. I have a function called f and a function called a. You can see the definition for f on line 1. You get a variable, The variable is s is in the function, and I do s dot upper, which converts s to uppercase. And we're going to see if that changes the value outside the definition. We know it changes the value inside the definition. The second definition appends high to a list. So we're going to pass a list to the definition A and see if it actually appended high outside the list, outside the definition. So you can see on lines 7, 8, and 9, I set the variable x equal to hello. I call the function f sub x, and then I print x, and you can see above that the word hello is not changed to uppercase. So the variable s is an immutable variable because it's a string variable and didn't change the value, and it didn't change the value outside the definition. Look though on lines 10, 11, 12, or 11, 12, 13, where we have the list y. We pass the list y to the definition appended high to the list L, which is a different variable, but it's the same list because we passed it by reference. And you can see that, yes, in fact, on line 13, outside the definition, the list now contains the string high. So again, it's a little funny, but once you get into it, you'll understand. It'll make a lot more sense as you program some more. So we've seen passing values to a definition. Now, definitions can also pass values back out. That's why we call them functions, because a mathematical function, you give it information and it calculates and returns something. So we would expect the same from a def. We use the return statement within a def to return values away from, or to return values back to the def to value to the calling part of the program, excuse me. You can return almost anything: an integer, a float, a list, a string, a dictionary, an object. All kinds of things can be returned from a function. You can save the value that was returned into a variable by saying variable equals function. You can use it as in an expression, in a print statement, or some other mathematical expression. You can use it just like any other value, and once you define your definition, it actually kind of becomes part of the language. It's a new function that's just built into the language at that point. Well, added in by you. So let's look at an example of how that works. So I went back to the calc price example from a few slides ago, only this time notice that line 7 returns the round of price comma 2. So instead of printing the value out directly, this function, this version of the function now returns the number to two decimal places back to you. So you can look here on lines 10, where I calculate the price of one Fuzap at $2.45, and it returns the value and saves it in the variable this. On line 11, I then set total equals to total plus this, and you can see up on line 9, I initialize total at 0. So now total has $23.45 in it, and on line 12, I print one Fuzap costs this. I did this because I didn't want to call the function multiple times. There's no reason to. You're going to use the value more than once without recalculating or without a different calculation. Just save it in a variable. On line 14, you can see that I calculate the price of 12 Zitto flaps, and a Zitto flap cost $1.23. So you can see that I calculate by calling calc price 12, 1.23s, save it back in the variable this, which is just another variable, but I didn't care to keep the value from the first one, so I just used the same variable, but I could have used a different variable. I then added this to total, so that total now contains the total price of both items. I then print out 12 Zitto flaps cost, $14.02, and then I print out the total order. You can see that I just print out the total that I've accumulated by initializing it to 0 and adding the two items. So you can see now that the calc price function is so much more flexible. It's so much cooler because now instead of just printing the value, it returns the value that I can then use in other calculations and use in my program so I don't have to keep calling it every single time I need it. And if it was just printing it out, I couldn't then use that to add it to total or to keep it accumulated or do anything else with it. So there is a function that has arguments, receiving values, calculating values, has its own local variables, and then returns a value back out of the function. So there's a full function example. This concludes this brief introduction into definitions, aka functions, in Python 3. This presentation is copyright 2020 by me, James Reneau Ph.D. You can contact me at jreneau@shawnee.edu if you have any questions or if you see any errors. This work is licensed under a Creative Commons Attribution, Non-Commercial Share-alike 4.0 International License, and I would like to say thank you for your time today.